Okay, energy is, we said, is conserved. On the first module we said energy is conserved. That means you cannot create it or you cannot destroy it. If you have conservative forces, okay, that means the no loss of the energy in the form of friction, then we can talk about conservation of mechanical energy. For the mechanical system, if the only kind of forces or energy are potential energy and kinetic energy, the sum of potential and kinetic energy are becoming constant. This is the ideal case. That means, you're not losing any of this energy to the heat. In reality, there's not such a thing. You cannot convert all of the energies from one form to another, and some is always lost, but this loss is in the form of the heat. So if you add the heat losses to the potential energy and kinetic energy, then the total amount become a constant, and this is what we will see later on in the next module or a couple of modules down the road. We talk about the first law of thermodynamics, which is the law of conservation of energy. There's something called the golden rule of mechanics, which basically says whatever you lose in power, you gain in displacement. You might lose some of the work in the form of the heat, but doesn't mean that they losing the force. You can actually gain the force. This is done through the simple devices. And if you look at the simple devices, are those things that they make the life easier. They make the task easier. Usually it makes the task easier by reducing the amount of the force that you need to apply, or by changing the direction of the force in a more convenient way. In all of these cases, the output work is less than the input work, so you are having an efficiency which is less than 1. But then the way that you do it, you make the task simpler by carrying this force over longer distances. For example, an inclined plane or a ramp, you are performing the same amount of work whether it is a very sharp ramp or a very gradual ramp. The amount of the work is the same, but if you have a very, very gradual or lower angled ramp, then you have to carry this force over longer distances to get to the same elevation. A wedge, a screw, these are all the same thing. A knife is a wedge. Basically, you are distributing the force over the both sides of a knife over a longer distance that the knife is cutting through, or an axe is cutting through the wood. These are all wedges. A screw is the same way, except that you are basically moving this distance in a helical way. You're having a long distance that you have to, to move, which is much, much easier, rather than just going and pushing a screw down a piece of wood. A lever, the wheels, the pulleys, they're all working in the same direction. You probably learned this in the physics, the very first course in physics that you took. And it doesn't have much implication as far as the energy in the form in what we're interested in this course. So I'm not really referring to these a lot more. The complex machines are only a combination of all of these simple machines. Any machine, you can reduce it with the motion of it, with this 6 kind of simple machine. It's a combination of those. A lot of pulleys, a lot of screws, and so on and so forth. Okay, this is an example. You want to carry a car. In this case, there's brake inside them that you want to use the three ramps. And so the 3 questions I'm asking: which situation requires the least amount of force? Well, you got it right. The one that is force, the least amount of force, is the one which is longer distances. Okay, and in this case would be the A, which situation requires the least amount of work? Doesn't matter. They all require the same amount of work. The question is the work is over what distance. So which situation requires the least amount of power? Well, that has something to do with how fast you're moving this thing on up. You can pull, the cart up, very, very rapidly, or you can carry it very slowly. So that has nothing to do with which of these three situations exists. It has to do something with the time that takes you to pull this cart over the ramp. So this is the example of a ramp. Other forms of machine, as I said, is a wedge, and this is a screw, which is basically a ramp that is turned around. And this is a screw. It's a still an inclined lamp. There's a lever. You can use a longer pole to push it down, then transfer it into a small distance that you lift the lever. A human person body is also a machine, just like the regular machine that uses some kind of energy to do certain performance of certain work, and some of the energy is lost. The human body is consuming food, converting to mechanical energy, work, converted to heat, and some of them has to be lost, different forms, maybe through skin, by sweating, or some of the excrements.